In an era where technological advancement is rapid and electronic devices are ubiquitous, a new form of mining is gaining traction: urban mining. This process involves extracting valuable metals, particularly gold, from discarded electronic waste, e-waste. As traditional gold mining becomes increasingly inefficient and environmentally problematic, urban mining presents a promising alternative that could revolutionize how we source precious metals. The golden problem. Traditional gold mining has become astonishingly inefficient. A 2024 report revealed that producing just 1 kilogram of gold requires processing a staggering 3 million kilograms of ore. This inefficiency not only makes gold extraction costly, but also raises significant environmental concerns. The extensive mining operations required to extract such small amounts of gold lead to habitat destruction, water pollution, and contribute to climate change through increased carbon emissions. However, there's a glimmer of hope in an unexpected place: our trash. Humanity has inadvertently created a vast reservoir of gold in the form of discarded electronics. In 2022 alone, an estimated 270,000 kilograms of gold were thrown away, primarily in electronic waste. This represents a value of approximately $15 billion at current gold prices. Gold in electronics. The presence of gold in electronics isn't a mere luxury. It serves crucial functions. Gold is an excellent conductor of electricity, highly malleable, and resistant to tarnishing. These properties make it ideal for use in circuit boards, particularly at connection points between different electronic components, and for bonding wires together. While the amount of gold in any single device is minuscule, the cumulative amount across billions of discarded devices is substantial. In 2022, global e-waste production reached an estimated 62 million metric tons. The gold content in this waste represents a significant untapped resource. Some estimates suggest that up to 7% of all mined gold may be tied up in e-waste, though precise figures are challenging to confirm. This could potentially represent up to $1 trillion worth of gold simply sitting in landfills and recycling centers worldwide. The rise of urban mining. The concept of urban mining, first coined by Japanese researchers in the 1980s, has seen a resurgence in recent years. This process involves collecting and extracting precious metals, including gold, from discarded electronics. As the environmental and economic costs of traditional mining continue to rise, urban mining is becoming an increasingly attractive alternative. Current recycling rates for electronics hover just above 20%, indicating significant room for improvement. Increasing these rates could substantially reduce the need for new gold extraction, mitigating the environmental impact of traditional mining. Challenges and innovations in urban mining. While urban mining holds great promise, it faces several challenges. Current extraction techniques often involve either melting the electronics to separate the gold or using specialized acids to dissolve the components. These methods can be inefficient, resource-intensive, and may release toxic compounds, contradicting the environmental benefits of recycling. To address these issues, researchers are developing innovative extraction methods. For example, protein-based extraction. In 2024, Swiss researchers published a study describing a novel extraction method using an aerogel made from amyloid nanofibrils, a byproduct of cheese production. This fancy sponge was able to extract gold from a slurry of dissolved circuit boards. Microbial extraction. An Australian startup is exploring the use of microbes in a proprietary gold extracting solution, leveraging biological processes for metal extraction. 3D printed filtration. Researchers in Finland have designed a 3D printed mesh to filter out non-gold components from dissolved electronics, essentially creating a modern equivalent of gold panning. These innovative approaches aim to make urban mining more efficient and environmentally friendly, although many are still in the experimental stages and not yet ready for large-scale implementation. The economic and environmental potential. Despite the challenges, urban mining is showing promising results. A 2018 study published in Environmental Science and Technology found that urban mining is becoming more cost-effective than traditional mining. Furthermore, a 2024 paper in Nature Geoscience predicted that by 2050, recycling of rare earth metals like gold could meet up to 40% of demand in the US, China, and Europe. The potential benefits of urban mining. extend beyond economics. By reducing the need for new mining operations, urban mining could significantly decrease the environmental impact associated with gold extraction. This includes reducing habitat destruction, water pollution, and greenhouse gas emissions associated with traditional mining practices. Implications for consumer behavior. The growing potential of urban mining has implications for consumer behavior. As awareness of the value contained in e-waste grows, consumers may be more inclined to properly recycle their electronic devices rather than discarding them in regular trash. This shift in behavior could significantly increase the supply of e-waste available for urban mining, making the process more viable on a large scale. Moreover, manufacturers may be incentivized to design products with easier recycling in mind, potentially leading to more modular designs or the use of materials that are easier to separate and recycle. This could create a more circular economy for electronic devices, where the materials from old products are more efficiently reused in new ones. Challenges and future outlook. While urban mining shows great promise, several challenges need to be addressed for it to reach its full potential. Collection infrastructure. Efficient systems for collecting and sorting e-waste need to be developed and implemented on a large scale. Technology development. More efficient and environmentally friendly extraction methods need to be developed and scaled up from laboratory experiments to industrial processes. Economic viability. The cost of urban mining needs to consistently undercut traditional mining to drive widespread adoption. Regulatory framework. Governments need to implement policies that encourage e-waste recycling and urban mining while ensuring environmental and safety standards are met. Public awareness. Increase public education about the value of e-waste and the importance of proper electronics disposal is crucial. Despite these challenges, the future of urban mining looks bright. As traditional mining becomes increasingly costly and environmentally problematic, the economic and ecological incentives for urban mining will likely grow stronger. This could lead to increased investment in research and development, potentially accelerating technological advancements in the field. Conclusion. Urban mining represents a promising solution to the dual challenges of meeting global demand for gold and reducing the environmental impact of traditional mining. By tapping into the vast reserves of gold locked away in our discarded electronics, we have the potential to create a more sustainable and circular approach to metal extraction. As research continues and technologies improve, urban mining could play a crucial role in reshaping our relationship with electronic devices and precious metals. It encourages us to view our discarded electronics not as waste, but as valuable resources waiting to be tapped. In doing so, urban mining could contribute significantly to a more sustainable future, where the gold in our devices of today becomes the raw material for the innovations of tomorrow. The next time you consider throwing away an old smartphone or computer, remember, you might be holding on to more gold than you think. As urban mining technologies advance, that outdated device could be worth its weight in gold quite literally.